All right, let's take a look at the adapter design pattern in this lab. So the adapter design pattern is one of the 23 well-known Gang of Four design patterns and is classified under the category of structural patterns, and it is used to provide an elegant and efficient way to work with two incompatible interfaces. So whenever you have an interface that is incompatible with another one, so you have a class that takes an object that you do not expect, then you may use the adapter design pattern, right? So we'll be working on a real world scenario. We're trying to implement this design pattern, work on TDD, test driven development. We will need Java 11 because we're using the HTTP client that was introduced in Java 11. And we will be using IntelliJ IDEA because it just works nice with Maven. All right, our build automation and dependency manager. All right, so let's get started. So click on the link below and accept the assignment on GitHub Classroom. So select your section and click on the link. So already clicked on the link right here. So accept the assignment and then we will reload the page once it's done. So reload, and then we'll get a link to the repository. So click on the link. So this is our private repo. So let's clone it, copy the HTTPS URL, and then go to the terminal and run git clone, passing the URL. Right, so this should download the lab into our home directory. So we go there, and then I'm going to open it in IntelliJ IDEA, right? So let me grab IntelliJ IDEA. And then I will open it. I will select the path. Let me grab it here. So click on open, and then I will select the project. All right, select where you downloaded, where you cloned it, and then open it. Click trust. And now this should be opened in IntelliJ IDEA. All right, so we just zoom this. So we get the source directory with our Java classes and interfaces, and then we get the test file. All right, so let's take a look at the pom.xml. So you see we're using Java 11. So make sure that you select Java 11 in your IntelliJ IDEA. So you go File, and then you go to Project Structure. So click on File, Project Structure, and then select the SDK. So you already have Java 11 downloaded. If you do not, you need to click on Add SDK, download JDK, and then you will need to select JDK 11 and then download it. All right, anything above JDK 11 should work, but just to be sure, I just want to select JDK 11, and then you can select any vendor, is fine. All right, I'm using the one from Amazon. So you could click on download. I already have it, so I'm not going to click download. Just make sure that you activate it, you turn it on, that this is a JDK 11 project. All right, so now we're good to go. So this is our POM. So I'm going to reload it, reload the project. Since I changed the SDK, just want to make sure that my project is ready to go. All right, cool. So let's go back to the project description and see, take a look at this scenario and how to solve it using the adapter design pattern. So we got this problem where a developer is working on a fully customized TV display for a business. This display will list weather information, local transportation information, business related offers messages on a TV screen. So she started working on the subsystem that shows the weather related information. She wanted to allow the user to get daily weather forecast by entering city name, And then she started exploring existing APIs, found them to be complicated and expensive. So as she explored, she found an API. That API is an open source API, the free weather API, that takes geolocation and return the weather forecast. So let's take a look at the API that she found. So this is the API, the free weather API. If I click on the last 10 days, and these are some historical forecasts. So if I click on this link, copy the command, the curl command, and then paste it into my terminal, I should be getting the response from the API. So this API requires no API key. So if I send this on curl, you can try this in PowerShell if you're on Windows, and we get the response. All right, so you get a JSON response. We need to parse this and deserialize it into a Java object. All right, so if I open this in Postman, if I put the URL here, let me just remove the curl and the quotation marks at the beginning and end, and then send a request using Postman. You can download Postman to your desktop or use the web app. So here are the parameters for this request. So if I send the request, I'm getting 200, so I get the hourly forecast, right? So I don't want to get the hourly forecast. I want to get the daily forecast, not the hourly. So let's take a look at the documentation, see what endpoints we can call to get the daily forecast instead of the hourly forecast. So here's the daily. So if we send daily as a parameter instead of hourly, so I'm gonna send daily and see if this works. So this is latitude and longitudes are required. The rest it says no, not required. And here the additional parameters for the daily. So whenever we say daily, these are additional parameters we may use. So we want to see the temperature max, the minimum and maximum daily air temperature. So let me just remove these and then put the one that I need. So temperature 2m max and 2m min. All right, so the minimum and the maximum temperature. We can also get the sunrise and sunset, right? So I put comma and sunrise, comma, sunset, and let's send the request. Oops, I'm getting 400 error. Let me see. Let me see if I'm missing something. Past days is not there, so I'm going to remove this past days. Send the request. Oh, still 400. Oh, it says time zone is required. All right, so that's the reason. So I need to set the time zone. Let me just see what is it called. What is the parameter name? What is the exact name for the parameter? It's not listed here. Let me see. Search for it. Oh, time zone is here. So the parameter is just time zone. I want to select our time zone. So only Africa, Cairo, Asia, Bangkok, Singapore, Tokyo. All right. So I'm gonna just copy this and then I'm gonna put Asia, Kuwait. I think that's a valid time zone, and see if the API will take it. So Kuwait, and then send. Yeah, we get 200. Great. So now we got the daily forecast for the next 5 days, right? Today and the next 5 days, and the maximum temperature for these days in an array, right? And sunrise and sunset, all right? So I believe the requirements for the API, we do not need to use sunrise and sunset, so you can remove it later. The point of this problem is she's trying to use an API that takes a city name instead of latitude and longitude, right? Geo coordinates. So she wants to make it easier for the user of this TV display to just type this or select the city name, and then they get the weather without entering these geo coordinates, right? So this is what the API expects, and her program expects another object or another interface. All right, so we get this incompatibility between her system and the API, so she needs to fix this using the adapter, right? So let's look at her design goals. So some APIs provide incompatible interface with her system, right? So she wants to solve this incompatibility issue, and she wants also to be able to replace the weather API with any other service with minimal changes to the code base. So she doesn't want her code to be tightly coupled to the concrete implementation of the API. So she wants to be able to change the API on the fly. All right, so we'll solve the first one using the adapter design pattern. So we're going to write an adapter that acts as an intermediary between her class and the API. Right. The second one will be solved using the program to an interface, not an implementation principle. Right. So if we design our code to be around concrete implementation, then we get tightly coupled code that is harder to change. But if we design it around the interface, it will be easier to change, right? So these are the API endpoints that we need to send a request to. This is what we did in Postman. We need to parse it in Java and then deserialize it into an object, right? So let's look at her code implementation. So she started writing an adapter to fix this incompatibility issue. So she wrote two interfaces, weather city and weather geo, for the geo coordinates. The weather API is defined as a class, the open meteo weather, which implements the weather geo because it takes geo coordinates. So this is the class that implements this interface, and then she will write an adapter that implements the weather city interface, and we will be using basically composition or association between the weather adapter and the weather geo adapter, so that way we can change the concrete API without changing the adapter, right? So we'll implement the weather city and the weather geo API here. So you write these interfaces, write the methods, get weather info. One will take a geo coordinates, the other one will take a city name as a string, right? So this will take a string and this will take a geo coordinate, right? And this is the concrete implementation for the adaptee, right? This is the class that takes geo coordinate and retains the weather forecast. This is the class that is incompatible to the client code that she's writing, right? So we have this weather info, and we will build a URL, right? This is the builder design pattern. You see it right here. We're adding parameters, optional parameters, and then we call build at the end, right? So this is what we did in the last lab, okay? So so that's how you set. So we don't need to set the sunrise and sunset. We will send a request for only the daily weather forecast, right? So this is what we will send, right? So we build this URL, and then we send an HTTP request. We have a helper class that will send this HTTP GET request, and then we parse the response, right? So parsing the response, we're going to be using the Jackson library and the object mapper to go through these elements and deserialize them into a Java object. All right, so we call the get the daily. So you see this one has daily. So this is the property daily, and inside daily there is time. So we say daily, it's actually up daily, and then we call time. Right? And then we're using an iterator. That's a design pattern you'll see next to iterate through the list of dates and then iterate through the list of yeah, we create a list of dates and then get the actual values for the dates here, right? And then for the temperature, we do a similar operation where we get the maximum temperatures in an array, and then we will convert that into an object and a weather info object. So we did the deserialization and then we return it to the caller, right? So this is the adapter class. The weather adapter should implement the weather city because it will take weather city, all right? And basically will act as an intermediary between the adaptee and our client code, right? So we'll complete the code using the adapter, and then we will answer the last question to explain how the adapter design pattern binds the client to an interface, not a concrete implementation, right? So let's dive into the code. Take a look at the Open Meteor Weather API. And the weather geo. So let's start with the interfaces first. All right. So this is the weather geo that will take geographical coordinates, the latitude and longitude. So we'll write the method that will return weather info, and it's called get weather info, and we'll take latitude and longitude, right? And those are double values, right? So just write the signature of this method, right? And the weather info is just a simple class defined here that describes the weather information. So latitude, longitude, city, and the list of dates, an array list, and an integer array of max temperatures and min temperatures, and then a bunch of getters and setters. All right, and then the toString, we also use the builder design pattern, the string builder class, to return a nicely formatted text message, right? So let's do the same for the weather city class. So this class will take a string city name and retain a weather information, all right? So weather info is the return type. And then let's see. So yeah, let's just name it get weather info, and we'll take a string city name. Right, I think something not right. I need to remove public. We don't need to define the visibility of the method. Leave it to the concrete classes. This is not the job of the interface. So let me remove those public keywords. All right, just the method name and the return type and the parameter that it takes. This is what you should be putting in an interface. All right, so this will declare the weather geo that will take geo coordinates, and the weather city will take a city name. And remember, the API will implement the weather geo, so it will take latitude and longitude. This is already implemented. All right, so we implemented this this method, the get weather info, that will return the weather information by latitude and longitude. All right, so let's go to the weather adapter. So in the weather adapter, remember this class basically is used as an intermediary between the client code, her client code, and the adaptee. And the adaptee is the Open Meteor Weather, right, which implements the weather geo, right? So we shouldn't be referencing the concrete implementation. We should be, so let's first implement the weather city, right? And here we should be creating an instance variable of type weather geo, right? So this should be um, type that will reference that Open Meteo API. So let's call our service. So we have a service that will do this intermediate operations called geolocation service. So you basically it's just a list of hash map where keys are the city name and the values are the geo coordinates, right? So we'll take a string name, so Mecca, Medina, Jeddah, on all the cities, and the location, which basically a class that represents the latitude and longitude. All right, so just a class that describes the latitude and longitude, and then I have some equality methods, and this is the toString for that class. So, so this is the service that we will use to do this translation, the intermediate operation. So we give it a city name, and then it will return the geo coordinates, so I can pass it to the API. So the clients, they do not need to touch the API directly; they will touch the adapter class. All right, so these are so this is the reference to the geolocation service. So let's write our constructor. So our constructor will take a weather geo. All right, so weather geo, this is a form of aggregation, right? So this dot weather geo equal weather geo, and again at runtime this will be a concrete implementation of the weather geo interface, which is in our case the Open Meteo Weather API. All right, so let's initialize our geolocation service, and we need to override the method, right? So the method is get weather info, which takes a city name. All right, so let's go there and override this method, right? So I'm gonna annotate this and override, and then I'm going to be making it public, so it should return weather info, and it's called get weather info, and it should take a city name in the adapter, so city name, and now we need to do this translation, right? So we need to use the service, the geolocation service, give it a city name, and then it will return back to us a location, right? Which represent the latitude and longitude. So location, geolocation equal this dot geolocation service dot, and then we call the search method passing the city name. And then, so now we have the geo coordinates. Now we can call the incompatible adaptee class, right? Which we don't reference it by its concrete type. We refer to it by the interface that implements. So remember, we don't want to tie our code to a concrete implementation. Program to an interface, not implementation. So we do weather info. So weather info, that's what will return to us when we call that API. And then we call the weather geo. And then we call the get weather info. Right? And then passing the latitude and longitude. So it doesn't take an object, it will take latitude and longitude. So let's pass those. We call the getter inside the location class, and get those two values. So now we got the weather info, right? So now, since we got this weather info, we need to set the city name, right? Because this API that we call the concrete implementation does not set the city name, because it doesn't have a city name. So we need to use the setter since it was passed to us. So we'll set it inside the weather info, and then we return the weather info object to the caller. All right, So this will do the weather adapter implementation, takes a city name and then return a weather info object. All right. So this class acts as an intermediary between the client that basically that can work with the adaptee. All right. So let's take a look at the test. I think we did all the implementation. Just double check. This looks right to me. And so we did all the implementation. This is the main. So the main looks like it wasn't making use of the adapter. So I don't want to have this implementation. So I'm gonna make use of the adapter in the main class and then run it. Right. So let me comment this out. All right. So we don't want to be using this. So I'll comment this one out. So we'll be getting the weather for a city using the adapter. So the first is we refer to the weather geo, and then with geo, and through polymorphism we're gonna use the concrete one. So the concrete one is that incompatible API that takes a geolocation. So we create an instance of it, and the weather city. Remember, we refer to that by the interface, and then we use we create an instance of our adapter, passing the weather geo interface, which is in runtime will be the incompatible API. All right, and then we need to call the weather city, get the weather info from that weather city, right? So that will return weather info. So we call weather city dot. So we refer to it by this interface, right? So that's the adapter. So the weather city adapter dot get weather info, right? So we're gonna call this dot get weather info, and then we pass a city name, right? So let's give it Jeddah. And then that's it, right? So we got the weather info. So let's print it out, calling the toString method. If you print the object, it will invoke the toString of that object. So let's just get rid of this. I don't need to that code that's tied to a concrete implementation. So remove it and save it. And then let's try to run it. Right? So this should take some time to build and load the dependencies and then build the project and then run it. And we got the weather, right? So we get the weather for a city by its name, working with an API that takes only geo coordinates, right? So these are the daily forecasts, right? And we're heading to a more warmer days. So let's take a look at the test before we commit and push. So these are the tests. Please do not change those tests. This is what is used for the auto grading. All right, so this will check the weather geo interface. It should have one method that takes the parameters, the right parameters, and this should also check for the weather city interface. It should take one parameter, city name of type string, and then return a weather info object. This should test the adapter class, and this also should test the adapter method. And this is going to test the Open Meteor Weather API and making sure that it's working independently of other classes. And this is testing our geolocation service, and this is basically testing the whole thing with using the API. So this is similar to the code that we wrote in the main method. And here our assertions, right? So let's run this guy and hope for the green checks. All right. So it's running, 2 green checks, 3, 4, all great, right? So we got all the tests passing. This is great. So this was the test, and the unit test for this lab is now passing. Right, so now let's just push this to GitHub and get the grade. So we run git status. We need to add those under src main, right? And make sure you do not change the unit test code, so just add the ones under src main and run git status again. So these are ready to be committed. So these are staged. So we run git commit, give it a message. Completed lab, was it 5? And then I need to push it to GitHub. Right, so let's run git push origin main. So that's got pushed into GitHub. So this was the last commit by the GitHub Classroom bot. So let me reload, and now I see my commit. All right, so let's click on the details of the build. This actions, under actions, the workflow. So this will run the workflow, and wow, we got green, right? So all tests passing. Right, so now it will take some time for the auto grading to kick in and record the grade. Wait for the check mark. We got the green check mark. That's great. So this is the auto grading with all these log messages. Scroll down. Already saw it. I just want to double check again. So lab part test, all test passed. Right, and we got 100. All right, so that's how you implement this. What is left right now is the second question. So we did the first question. The second question is asking you to explain how the adapter design pattern binds the client to an interface, not a concrete implementation. Right, so you need to write your answers in the README file for this question. All right, this will not be checked by GitHub Classroom, will be checked manually by your instructor. So make sure you write your answer here. Right, so you open the README file and write your answer for question 2, right? Which asking you to explain how the adapter design pattern binds the client to an interface, not a concrete implementation, right? And basically, if you look at the source code, all our implementation for the adapter, we're referring to the incompatible adaptee by its interface type, right? By the interface that it implements, not the concrete class. So that way, if we change the API, we get another API that implements Weather City, not the Open Meteor. We get another API. The adapter still will work with that API, right? As long as the API implements the Weather City. So if we run into another incompatible class, since we're referring to it by its interface, not the concrete implementation, then we can swap this Open Meteor Weather API with another incompatible API, and the adapter class will still work because we're not referencing the concrete type, right? This is very important, right? So APIs, this API may disappear and they may introduce pricing or API keys or something complicated. So make sure that you implement to an interface, not an implementation, right? So make sure you add this README file when you put your answer, and then commit it, and then push it to GitHub, right? So git add readme .md, and then commit with a message, and then push origin main. So this will push the readme file to GitHub. So if I go to GitHub repo, if I go back and then reload the readme file, so this is the readme file. If I reload the page, I should be able to see question 2, right? So be sure. So this unfortunately kicked the workflow. It shouldn't be kicking this. It must be an ignore file for GitHub workflow. We'll check that later, but this is fine, right? We didn't touch the code, so it should pass again, right? So if I click on details, click on details again, and now getting the auto grading green, and that commit did not break the implementation, didn't touch the code, obviously, right? So that's how you do the adapter design pattern. Thank you.